In this video, I will be covering how to project oblique and axonometric 3D digital models into 2D digital drawings. My working file is available on Canvas if you would like to follow along. Let's get started. As you can see, I have divided up the workspace into 3 sections: axonometrics, plan obliques, and elevation obliques. For each of these sections, you will find the original 3D model, the projected 2D drawing, and the auxiliary view cube, which calls out the angle of the receding lines, as well as the principal face, which is hatched. For each of the oblique examples shown, I have provided a predefined macro, which you can use to make your own oblique drawings. A macro is simply a string of Rhino commands. This macro, for example, is telling Rhino to set active viewport to top, rotate 45 degrees, then select active viewport to the right and shear at 45 degrees. Then it finishes by setting the active viewport to the top. Let's go ahead and try an example. I'm going to double click on the macro to get this edit text window to pop up. Then I'm going to copy that text, click cancel. Hidden, I have a 3D model of a chair. So I'm going to go ahead and zoom selected on that chair. There it is. And now that I have the object that I want to shear selected, I can go to that command line, paste my macro, and hit enter. And now what we have here in the top view, our chair is rotated. In the right view, it's sheared 45 degrees. And in the front view, it's ready to be made 2D. So now I can just select that chair, I can make 2D, won't fuss with the details, and you can see that we have an oblique drawing of the chair. It is important to note you must have ortho disabled for the macro to work properly. Take a moment to look at the variations in representation achieved through the oblique projection before we move on. First, we have the isometrics. All 3 principal faces are equally inclined to the picture plane and are foreshortened equally. Note that a projection foreshortens the drawing, noted by the outline here. In order for the drawing to become measurable, we must scale up the drawing slightly. In an isometric drawing, all 3 principal axes 120 degrees apart on the picture plane. In a dimetric drawing, one axis is measurable and the other 2 are foreshortened an equal amount. And in a trimetric drawing, all 3 axes are foreshortened at different rates. To project a dimetric drawing, first make sure your view is set to parallel within your viewport properties. And now you can use your view cube to place our camera and target. Note that there are many possible diametric views of this object. The first click will place the camera, and the second click will place the target. Anywhere along this line will give you a diametric view, as well as along this line here. If I was to click on this rear point, I would have an isometric view. Once you're in a view, it is important that you do not orbit or pan in and out, but rather use the zoom selected command before you make 2D. Let's go back to a diametric view. I'm going to place my camera and target again. And this time, I will click to the midpoint. Now I'm going to zoom selected and make 2D. I'll make sure that my view cube is selected as well. Before making 2D. Return to top view. And you can see that this new drawing is a variation from the other. Using the distance command, I can find the two axes that have been foreshortened the same amount, and the third which has been foreshortened more. I'm going to select this entire drawing and then scale. Use the scale command to return this drawing to the correct scale. And now I can check to make sure that the view cube remains at 1 inch on 2 axes and foreshortened on the third. This concludes the axonometric and oblique projection tutorial. I hope you have found it helpful, and if you have any questions, please feel free to contact me.